Went through one example yesterday, but we're going to go through another one. So you ready with this, with your notes? Your books are all open? Okay, so let's go through. Here is a right-angled triangle. I'm going to tell you that this is the side I want to know. This angle is 51 degrees. And the hypotenuse, I've already given that one away, is 12.1 millimeters. Okay? So remember I said to you I would like to start with a certain layout of your solution. So I want to work out x using this information. So we know it's going to be trigonometry. How do I know I'm going to have to do the SOHCAHTOA thing? What's the clue? I look at the diagram, I see, first of all, I see a...
you see a side line.
What's the first thing I see, though, before you even look at that?
A triangle.
A triangle. And a specific type of triangle?
A right angle triangle.
A right angle triangle. Right, and then you see...
Oh, I have a question.
Go on.
Can't you do trigonometry like with other triangles? It doesn't have to be a right angle.
The ratios that we're using are all for right angle triangles. You can use sine, cosine, and tangent in another way with other triangles, but not in the way that we're using them at the moment. This is the first step. All right. So I see that. I see a right angle triangle. All right. The next thing I look at, why is it not Pythagoras' theorem? Yeah.
You only have one side.
We only know one side. There's another clue to think, oh, it's probably going to be trigonometry, which is?
We have only one angle.
Well, the fact is we have an angle. What do we never get given in a Pythagoras question? An angle, because we don't use it in Pythagoras theorem. So if we see a right angle triangle with an angle written in it, then we kind of go, oh, that's probably trigonometry. Got it? All right. So trigonometry means we have to pick one of the ratios. So SOHCAHTOA. I have to pick one. I'm going to write theta, opposite, adjacent, hypotenuse. I've got to identify which is which. So I've already told you that the hypotenuse is 12.1. Theta is the angle, so that's 51 degrees. Okay? The x is which one? No? It's not. It's the adjacent. So if you remember I said, look for the hypotenuse and then make the angle. And the other side is the adjacent side, so the x is the adjacent. So the adjacent is x, and the opposite is don't know, don't care. So I can cross that out, which means any one of these ratios with an O can be crossed out. So then I know it's this one, so it's the cosine of the angle is equal to adjacent divided by the hypotenuse, which means I can then put these numbers in here. So I've got the cosine of 51 degrees is equal to x divided by 12.1. Now, one thing to say. Cos of 51, I'll put a little set of brackets in there. What was the way of saying cos 51 correctly?
Cosine. It's a cosine of the theta.
So cosine of the angle, yeah?
Is equal to x.
Okay, is equal to... But it's that thing of cosine of the angle. What's the angle in this question?
51.
Right. So just, I'm saying that for a mistake that I have seen, which is sometimes people, when they start rearranging the equation that we've got, they swap the 51 with the 12.1. All right? And that makes no sense if you're used to saying cosine of the angle, not just cos number. Does that make sense? Right? So if I said cosine of 12.1, it doesn't make any sense because that's cosine of a side. And cosine is of the angle. All right? And cosine of 51, well, can I just get you to tell me what that is as a number? So I've got x divided by 12.1 is equal to the cosine of 51, which is 0.6.
2. No, 0.63.
We've rounded it, okay? All right. Now, remember I said yesterday it'd be quite good if we don't round it, but I just wanted to have it written in this way. So how now do I find x? Okay?
You times 0.63 by 12.
So we multiply both sides by 12.1. Okay? That gets rid of it, the division. So I'm left with x equals that. So you can tell me what that is.
7.6. Oh.
Then the final step should be, we should always do our checks in maths. So I'm actually going to, even if you're happy, I'm going to write that up in my diagram and write 7.623. And I'm going to look at that and go, does that make sense? Well, we know it's got to be shorter than the hypotenuse because the hypotenuse is the longest side, and that's 12.1. So the only check I'm not checking check my maths. I'm saying first check is, does it make sense? 7.6. Yeah, makes sort of sense that the other one's 12. If Desmond had written 76.23 and just written it here, and not bothered to check his diagram, he might have just left it as 76.23 and then not thought, actually, it can't be 76 because this side is only 12, so that doesn't make sense. So try and do that check. All right, so that was a recap of yesterday's example. That all right? Make sense?
Yeah.
All right, so I'm going to do another one. Okay, and this time, so here's my triangle. I'm going to make x here, so this will be 3, and this, oh, sorry, no. Yeah, all right. I'm actually going to label this one as 14 degrees. Okay. So what do I start with? SOHCAHTOA, so let's write it down. SOHCAHTOA. Put my lines in just to, so I know that all those three go together. I'm going to write my theta, opposite, adjacent, hypotenuse. I had a word with someone yesterday that was doing it, and they couldn't understand where the next step would come from. It's because they hadn't written all 4 of those down. Now, part of the important process is knowing which one that you're not using. All right? If you just write down the ones that you have on the diagram, then it's not obvious to start with. So I kind of make a symbolic act of actually crossing one out. Yes? Okay, so the hypotenuse is x. Theta is 14. Which one's 3? That is the opposite, yeah. So the opposite is 3. So we don't need A. So we cross out.
No.
So we can use SOH because it's not got an A in it. So that means I'm using sine theta equals opposite over hypotenuse. Now eventually you'll start cutting out these parts and you can just go straight to writing it out with the numbers. Right? You can look at it and go, I know what that is. But just for the moment, while we're getting used to it, because it's a real shame, it's a real easy, step by step, write it down. And the number of people that try and skip it all to start with, and then just, they choose the wrong sides, they choose the wrong ratio, and there's no way for them to check what they did and why. So this is a good way to at least start it. So we've got sine of 14 equals 3 divided by x. So what do we do? This is a big moment here. This is where mistakes are made.
So the sine of 14 is from 0.24.
Okay, you want to do 0.24 equals 3 over x. Oh, because he didn't know his calculator. Do we all know how to know what sine of 14 is?
Oh, that's a, wait, is that a 14? Oh, that's a 14.
I didn't.
I thought it was a 16.
Yeah, I know.
You all know how to find sine of 14 on your calculator, yeah? Everyone?
Yeah.
Yeah.
Okay. So what do I do now?
X times sine of 14
Okay, so what would normally happen, by the way, so I'm going to put this in bright red just so you know it's a mistake, is at this stage people would do this. 3 times 0.24 equals x.
Yeah, that's what
All right? Because they don't think about the maths that's actually happening. They look at, they have a template from the previous one and they go, oh, well, you take the number that you know and you multiply it and that gives you, but what if I actually did that? All right? So I tell you what, I don't want you to write this because it might confuse you looking back at your notes, but if I actually multiply by 3, what do I actually get? So I'm going to do this over here. 0.24 equals 3. And hang on. If I multiply both sides by 3, right, so I get that on this side, is what you're saying. What do I get left with here, though?
X.
You don't get left with x.
No, you get,
So 3 times 0.24 is what?
well, it's 9 over x. Because
So this one's fine. Can you do 3 times 0.24 for me? What'd you get?
0.72.
0.72. So that would be fine. It'd be useful. But what appears on this? Well, 3 lots of 3 divided by x is actually 9 divided by x, which is not what I want. Okay? It's not what I want. Doesn't tell me x at all. And what you've done is you've thought of, because we talked about this last year, in that the algebra, you're thinking of it as blocks that can be picked up and moved. So what you're kind of doing is saying, right, here's the 3, I'm going to pick that up and I'm going to move it over there. And that leaves an x on this side. But it doesn't. It leaves a divide by x on that side. And that's not the same as an x. So what we need to do is we need to actually think about the mathematics that is happening rather than picking up things and moving them. All right? So I will never say to you, oh, we have to move that to the other side, because I don't think that works with your thinking. All right? What I do is, I think we did this a lot last year, was to think about the language, what's actually happening. So this is 3 divided by x is equal to 0.24. So what would be an equivalent statement that would mean the same, or use the same things? So if it doesn't make sense, if you don't know what I'm talking about, what we can do is we can write a different question which is easy to deal with, all right, but using easier numbers and the same structure, concept. So what if I write something like this? 4 is equal to 8 divided by 2. Is that true?
Yeah. Yes.
Yeah. How would I write another statement where the x is involved? So I want to know what x equals. That's what we're looking for. But so what would be an equivalent statement that I could make using 4, 8 and 2? Well, I could say, if I multiplied by 2, I'd get 8 equals 8. All right? Or to break it up so you can see what's happening, 2 times 4 equals 8, yeah? Another statement I can make is if I then divide this by 4, I get 2 equals 8 divided by 4. That's also true, right? So we have to follow this structure using numbers that I know how to do, all right, and apply it to just the same structure but different numbers. So the first stage, which is what Jack was trying to tell us earlier, which is, first of all, you don't multiply by 3, you multiply by x. And that gets rid of it from that side, but it does now have it on this side. So I've got x multiplied by 0.24 equals 3. So I can see it from here. That makes sense. That must be true. All right. Now what's the next stage? Divide by 0.24 and I get x equals 3 divided by 0.24. So that gives me what? 12.5? All right. Now, hopefully, I will come back to this if you're still writing. If I put 12.5 up there, does that make sense? Well, it's longer than the 3, but around the same sort of idea. Yeah, it makes sense. Now, looking at what I've done, can you think of a short method where you go, oh, yeah, I don't need to do all those steps? Can you think of a short method of, yeah, I could go straight there next time? So look at where we started. Okay, there's our start. Where I finished was here. Now what I might do, I know Desmond gave me the 0.24, but I might put in bracket what it was to start with, which was the sine of 14, and that might help you to visualize what's happened. So can anyone spot a quick way? So I'm looking at this and I'm comparing it to this. That would be an easy way of, they just swap, right? You can see what we've done to get it to that point, but maybe a quick and easy way is like, I know if the unknown is on the denominator of the fraction, I can just switch those two around, yeah?
Yeah.
Now, I only want you to think that way because you understand how it gets there,
Yeah.
rather than that's what happens. That's not what happens, it's what looks like happens. Right? Does that make sense?
Yeah.
So that one you did yesterday where you were getting some wrong answers, now you know why, is because you were making the same mistake everyone makes. Right, there's one final one I want to go through with you today before I let you carry on, which is, well, we've figured out how to work out one of the shorter sides using the ratios. We've figured out how to work out the hypotenuse, or the one that's on the denominator, right? What's left to figure out? What have we not been asked to work out yet? Well, we haven't used tangent, but tangent actually just does the same thing, just with different sides. So we're still working out side. You're right, I haven't used tangent, but it's basically the same as the other two. There's one thing we haven't calculated yet.
What was your adjacent?
The angle, good. We haven't been asked to calculate the angle yet.
Which, or the angle of the other side.
Well, no, just what happens if we have a triangle. So here's a triangle. I know it's a right angled triangle. I know the hypotenuse is, let's say, 18.6 meters. All right. Actually, no, sorry, can I stop there? I'm just going to, sorry if you've written that, just cross that out. I'm going to make this one 18.6 meters and this one, what should we say, 9.2 meters. Okay. And I'm going to ask you to find this angle, theta. So this time I know two sides, not one side, but I've got to find the angle that goes with those two sides. Because those two sides are in a ratio, right? So I should be able to work out the angle, because the angle is the same as long as I know the ratio, right? Yeah, do you remember we had one angle, gave me lots of triangles, but the ratio was always the same? So if I can figure out the ratio, I ought to be able to figure out the angle. Okay, so let's go through the process. Go on.
Don't you have to do side angle to get that hypotenuse?
You can ask a question. Could I do it, or do I have to do it? Now, there's a different answer for each question. Which one are you asking? Do I have to? The answer to that is no, I have enough information. All right? What do I need to use a trigonometric ratio? How many things? 2. I either know 2 sides, like I've got, or I know an angle and a side. I only need 2 things. 2 angles, would that work? No, because that could give me any size of triangle. Right? So, let's do what we've always been doing. SOHCAHTOA. Nice to know it's exactly the same thing as before. Theta, opposite, adjacent, hypotenuse. The opposite is? No.
No, 18.
Yeah, because remember, here's the hypotenuse. Here's the makes the angle. That is therefore the adjacent. So,
It's always opposite the theta.
9, yeah. The opposite, the theta, is the opposite side. That's why it's called opposite. So the opposite is 18.6. The hypotenuse, don't know, don't care. So that means I can get rid of that one, get rid of that one, and I'm left with tan theta. Yeah, we're going to find theta. Tan of theta is opposite divided by adjacent. Okay? So the theta is the thing that I want to know. So let's put in the information I have. Tan theta, tangent of theta, is equal to 18.6 divided by 9.2. Okay?
Wait, do you know which one's like, you know how you put like opposite divided by adjacent? Is that on that like thing you told us the other day? Like,
SOHCAHTOA?
yeah. But like, how do you know like which ones?
What do you mean?
Like, how do you know which one is top?
Because the first one goes on top, the second one goes above. TOA, T-O-A, I put the O on top, the A underneath. O-A-H, A on top, H underneath.
Oh, okay.
Yeah? Go in that order. Right, okay. Now, we have a slight problem. How do we get, because we've not done this yet, we've not figured out how do we figure out the angle from the ratio. All we've done is found the ratio from the angle, right? So we've got a new thing here, so you have to be all awake at this point. So there is a way, right? Now, if you were back in the olden days, before my time, there'd be a book. And you'd have to look up your book. All right? Stop ripping your pages out, otherwise I'm going to make you buy some more books. All right? If you want to eat paper, bring your paper with you, Jay. Okay? Right. What we've got, though, these days, we've got a lovely electronic book called Calculator. Right? It's all programmed in. Your calculator can work backwards. In the old days, you had to go in your book and look for the ratio and figure out what the angle was. Now we've got our calculator. Just like the calculator knows what the ratio is from the angle, it can go backwards as well. Okay, so what we do, this ratio goes with this angle. So what I need to do is say that the angle is equal to, well, if tan of the angle is that, then the angle is equal to what we call the inverse tangent of the ratio. Okay, the inverse tangent. That's what we should say. We've we've got the inverse tangent. And that's when we can put it in our calculator, and the calculator will tell us what angle goes with that ratio. Now you'll notice I haven't turned 18.6 divided by 9.2 into a single decimal. Why do you think that is?
To get a more precise answer.
Yeah, because it may well have to, I might choose to round that number, and I don't want to. All right? So I'm going to put it into my calculator just like that. All right? So you will notice on your calculator you have a sine button, a cosine button, and a tangent button, yeah, normally next to each other. And then above those, normally, you have another option which says, exactly, your second functions. And these, so you press your second to get the other one, yeah?
Second and then, oh yeah.
And if you then type in exactly what's here, so you'll then write, you'll type in second, right, the second button, then you'll press the tan button to get the tan minus 1, okay? Then you will do this, so you will put in 18.6 divided by 9.2, and you'll probably have to close the bracket and then press enter.
There's an error.
63.68. You probably forgot to close it.
No, I did.
Rounded to 63.7.
Oh, I know what I did.
Put it the wrong way round.
No, I put 18 point and never put after.
Oh, okay. What's our answer?
63.7.
63.7 degrees. Okay. Did you get that?
Yeah. 63.
Right.
63.68.
Now, I know there's a lot of talking at the moment, but I feel at this stage there's something we need to go through, because this is a point where potentially you'll get lots of error messages on your calculator, and I want you to know, all right, what those error messages might be. So what we're going to look at first, are you happy enough with those things that we've done so far?
Yeah.
All right. What we're going to do is we're going to have a special look, and I am going to be able to stop talking in just in a second, so if you bear with me very quickly, right? I would like you, using your calculator, all right, to figure out what the possible ratios are, all right? So, if we are talking about a right-angled triangle, all right, do you remember I said, we use one angle and we can get a bigger triangle and so on, yeah? Got that? So the ratio is always compared to this angle. So this is always a right angle. So what are the possible angles that I can work with in my triangle? From what to what? So theta must be greater than what?
The theta must be greater than
A number. What number?
the other
What's the
angle.
minimum angle it can be at the moment for our triangles?
80. Oh, minimum.
Oh, 60.
This angle.
990,000.
It's one. It's one.
It's not 1.
90.
0.
0.
I was right.
Not equal to 0, greater than
Be
0.
greater than
I could have a 0.01 angle, couldn't I? It'd be very small, but I could.
Yes.
What must it be less than?
Infinity.
No.
90 must be less than 90.
Must be less than 90. Why?
Because there's the other right.
Because we have a right angle set in stone.
Oh.
We're only talking about this one. So if I have a second 90 degrees, I have a cup. Yeah? All right, but I can have 89.99999 because the other one would be 0.0001. All right, so the other two have to add up to 90. So therefore, it must be greater than 0 and less than 90. So what I'd like you to do, I'd like to work together, all right? I want you to see whether you can come up with any conclusions as to, are there any limits for sine, cosine and tangent to the angles between 0 and 90? So all I'm asking you to do with your calculator, you can write them down if you want, but work together, all right? Maybe some of you start with sine. I tell you what, why don't we do front row, you work with sine, middle row do cosine, you two at the back do tangent. Are there any limits, like it can't be below this and it can't be above this, for sine of something? So for instance, I'll start with, I'm going to do the sine of 45. Do it with me. Sine of 45. What do I get?
0.70106787
Yeah, 0.700. So I know sine of 45 is that. All right? Can you find any limits? What do you think? Is there a minimum and maximum that the ratio could be?
Mine doesn't do
Right?
sine.
Sine, cosine, tangent at the back.
Wait, like, do we?
Are there any limits? Just keep plugging in some numbers. Can you find a number bigger than 7.707, or is that the largest one?
Oh, I was fooling around with this the other day.
Cool. We'll have a go, do it properly.